Hi, Mr. Hem again. So in the last video, we looked at vectors and radians and looked at how we resolve a velocity into its vertical and horizontal components so that we can use it to make the ship basically move. And this video, I'd like to continue on with our spaceship, and I want to use all of these things we've done to make our ship look and turn. Look as it like a ship, maybe it's like a triangle, and also turn based on the angles. Let's do that. Alright, so what we've done is we've got an angle that works and it does rotate. I guess I'll try a few more angles. Let me go 270. You should go downward. Yep. Yeah, so it's all good. Alright, so right now our spaceship is a sphere, and I don't want a sphere. I want it to look more like a spaceship. I want a triangle basically. So basically a polygon of 3 sides. So what I need to do is I need to draw a triangle with 3 sides, and I'll show you how to do that. Right, so what we're going to do is we need to know which way it's facing, which way the ship is facing. Okay, so I need to figure out which way the ship is facing using my vector resolutes. All right, but the issue is my vector resolutes yeah, actually I'll use this. Yeah, so what I'll do is I'll vector resolute, and I'm going to use a unit vector. What a unit vector is, a vector of distance of a length of 1. All right, and I want to resolute it, but the issue with this vector resolute is it is going to resolute straight into my v speed, h speed. This is not exactly what I want. This is more like a velocity resolute. What I want to do is I want to output my 2 components instead. So so I need some kind of, I don't want to like modify, I don't want to just put it straight into here. I want to get these values and you do other things with it, right? So what I could do is pause. All right, I've made a decision. I'm not going to change these straight away. What I'll do is I'll go H, I'll go delta H, dim delta, what's this, H? This one's H. This one's delta V, delta vertical, change in the vertical, change in the horizontal. Is that horizontal? Cos is horizontal. And then turn this into a function and output this, return a size of delta, new size. I'm going to not new size of delta H. I'm going to call it delta change in H. It's not, yeah, okay, sure. It should be H component. Vertical component. This is our horizontal component. This is our vertical component. Right? And then have another function that will resolve our velocity. So this is going to be specific context. Same inputs, but now I can actually call this one and use this one inside this other one and actually change our velocity if I want to. Pass in the magnitude, pass in this thing, an angle. I'll get some kind of components get our components, and then I'll put the components back into components back in dot. That's right, as size dot width dot height. So put the, and now everything should be the same, except now I have a function that I can use like generically. All right, now that I have a function I can use generically, this one over here, this was making it move. This will be velocity now. To be honest, I don't. This can be velocity. The velocity version will modify my velocity. This one will give me some values. So this is our direction we're facing. So I get the direction I'm facing, and then so what I want to do is I want to draw a triangle where, let's say I had a direction. I was facing in this direction. I get my horizontal and vertical components, basically my X and Y point, and that's going to be my nodes. And if I want to draw a triangle, say like this, where this is my right wing, and this is my left wing, what I could do is I could rotate my nose this way and then resolve this vector, and then rotate it this way and resolve this vector, and now I've got 3 points, and then I can use these 3 points to draw my triangle, because that's how our polygon drawer is gonna what our polygon drawer is gonna need. It's gonna need those 3 points. So let's do that. So I've got my kind of the direction, but rather this is they're gonna be our nodes. Actually, it's just a direction. We'll call it the direction of the nose. Now we need to get the direction of the left, the direction of the, too long, of the nose, of the right wing, and we're going to vector resolute again, the same thing, but this time around we're going to add. How many degrees is good? Just estimate. So since it's 3 points, we'll add 120. And so that's going that way. Going that way is not add, that's a minus. Rotating around and clockwise is minus. Rotating around anti-clockwise is a plus. Hope I got that right. Okay, so vector resolute. And then we go dim the left wing. So we've got our 3 points, and then what we can do now is we can just slot those points in. Dim points 3. There's 4 points here. There's 0, 1, 2, 3. So they say actually 4. As points. Point. Yep, and then we'll go points. First location, we're going to give it a new point. And these are you know what? I have to convert this. This is a size, right? I have to convert the size to a point. So I'm thinking maybe in here, instead of using size, I might just use point. So in our game object, going back to that to modify it, I might just use point instead. And then this will be my X, and this will be my Y. Alright, I think that's easier now. And over here, I can now just slot in nose. Slot in right wing. slot in left wing, and for the third location, go back to the nose. So it completes our bang, 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 and back. First point, second point, third point, and then back. And then now we don't want to draw. Well, I don't mind drawing that. To be honest, I need my references slightly off. I should go me.size. I want the center reference. I want a center reference. Me.size divided by 2. So I'll keep the sphere there. I keep the sphere there, but I also want to draw a triangle. I also want to draw a triangle. Fill polygon. So to draw a triangle, we use the polygon. But we only have 3 points. New brush. New solid brush. Now I want this a different color. So make it color blue. And it needs the points, and that's it. This is comma. Me.x.y plus. Okay, so I want to draw the polygon underneath the sphere. Now right now the polygon's only a unit circle, so I need to pull these. I need to give it a radius. So I need to make these bigger. I need to scale these really, because right now you won't be able to see it. It's like a unit. It's like a 3 dots on a circle that's of radius 1, and you won't be able to see that. You won't be able to see that. So I need to actually scale this. So what I'll do is I won't use 1. I'll use 10, maybe 20. Let's make this a big triangle. So that triangle's over here. So that's good. So that's fine. The issue is it doesn't know its position, the X positions, because these don't have positions. So what we need to do is we need to basically get our positions. We need to insert our positions in here. And the best way to do that is we need to slot it into here. So I can't do this now. I really do have to do this the long way. So we need to go me.x plus our nose direction .x, and then me.y plus our nose direction .y, and I have to do that for all of these, unfortunately. But you know what? Oh, that's fine. I was going to be lazy and actually just write a function that will do this once for me. You know what? I should. Since I need to do that for 4, I'm going to create a function up here that does a element-wise add for something like this. So what I'll do is I'll create a function called... what's the time? I'll do that in the next video.